So the eye is rather a remarkable structure. This is an eye sort of cut right down the middle, right? And you can see these various components of it. We're going to see that at the back of the eye is actually what's known as the retina. This is going to be a series of layers of cells, including some very important photoreceptive cells, cells that can absorb electromagnetic radiation within the range of visible light and convert it into a neuronal response. And that they're located in layers sort of at the back of the eye. And you can note also at the back of the eye here, there's this kind of like clear kind of spot here where there's lots and lots of blood vessels working their way in, right? And leaving. The red is supposed to represent, oxygenated blood coming through. These are arteries, right? Or, arterial smaller vessels that are carrying oxygenated blood. And then the blue are the venous drainage from the eye. And this is also where the axons of the cells that are going to actually carry visual information back into the rest of the central nervous system. These are going to be axons of cells that are known as ganglion cells, are actually located. So the axons are going to coalesce into a big cable here that's going to leave and form what we call the optic nerve. And there's an optic nerve coming from each eye. This is also the blind spot, right? Because the light that's going to be coming in here, we're going to see is not going to be able to strike any photoreceptive cells right here, because this is where all the vasculature and all the, the axons are kind of leaving, so there's no place for actual photoreceptors. So the eye, begins, there's like this outer sort of coating here. There's a protective covering, which is called the cornea. And there's no vasculature. There's no vasculature in the cornea, so it's clear, which allows for light to come through. But there is a humor called the aqueous humor behind it that helps to feed the cells that form the cornea here. There's also quite a lot of nociception in the cornea. A lot of nociceptors. A lot of specialized afferents that are capable of detecting tissue damage. And if anybody's ever had what they call a corneal abrasion, where you scratch that cornea, you're extremely well aware of it, and you favor that eye, pretty intensely because it hurts, which is for good reason. You want to protect your eyes, right? Then there is the pupil, right? That dark hole in the middle. And we always like to, tell kids when we visit classrooms, like, literally this process of stimulus transduction where you have cells that absorb, energy out of the environment and convert it, transduce it to something else. That's pretty well illustrated by the pupil, right? Because the pupil, if you get a flash photograph, all of a sudden you'll see red in the pupil, right? But most of the time you see black pupils. And that's because the pupil is going to be constricted, made smaller, or dilated to let in just the right amount of light so that all of the light that is being let in is going to actually be absorbed by photoreceptors in the retina at the back of the eye. So light gets in and it doesn't get out, right? You're like literally, you're looking around and pulling energy out of the environment and transducing it into a neuronal response. Again, if there's a flash photo, right? Too much light, and it turns out too much absorption, not any good informative input. It just looks like a great big flash, and you get reflection back, from all that vasculature, all that, the blood at the back of the eye. Now, the iris, right, is the colored, sort of pigmented, attached to muscles, surround. We can have, brown eyes and, practically black eyes and, green eyes or hazel eyes and blue eyes. And, that the darker it is, the more of the light actually gets absorbed at the level of the iris and doesn't make it in, to the pupil. So if you have like lighter eyes, it might be, you need sunglasses if there's, significant amounts of light in the environment. The lens then is this, initially flexible structure. So the light's coming in through here. Initially flexible structure here. There's muscles that sort of pull and can, help to bend the light rays, right? And then focus it on, the retinal cells, the photoreceptors at the back here. And again, initially this is flexible and clear. Although, when you're in your 40s and maybe early 50s, there tends to be a loss of flexibility in that lens. and you develop something called presbyopia, and it's pretty much inevitable. But you're gonna basically lose some flexibility, so it's harder to stretch that lens across the full range of bending of light rays that would allow you to focus on things that are really close and really far. And when people are tired, in particular, it gets harder to pull, and so their vision may get worse, at like late at night, or if they haven't had much sleep and things like that. There is some evidence, by the way, that because of our devotion to these screens, that some younger generations, are getting less kind of outdoor exposure, where you're, sort of, maybe hiking in natural environments, for example, and you're not. You would normally be looking close and looking far, and getting maintaining some flexibility in those lenses, and they may be developing presbyopia a bit earlier than some other generations. And then the other thing about the lens that's rather remarkable is how with lifetime ultraviolet light exposure, it causes the lens to get significantly yellower over decades. But what's fascinating is that people tend not to perceive like a yellowing, even if you actually look at the lens itself, if somebody who's 60 or 70, that it's quite yellowed at that stage typically, because of UV damage, and yet they don't perceive yellowing. They actually make adjustments in terms of how that input is ultimately routed to areas of the brain that are involved in your perception of color. So the eye is a really fascinating structure, and that's where the electromagnetic radiation and the range of visible light initially enters for stimulus transduction by photoreceptors in the back there at the retina.